It's a jeans day. I'm passing around the envelope thing. There's a lot going on. I'm going to have it start on this side of the room and on that side of the room. Ryan or Wyatt, whoever gets it, just put it on my desk. Unless somebody wants to do a quick field trip to the office, we can do that too. Ready, set, here we go. That food smells good. It's going to be a whole morning. Okay, what do we have given from the information? I don't need to read it because you guys already read it last night. True? So, 13 seconds to accelerate. It takes 13 seconds. So, we need to figure out our givens and try to identify what these guys are. Oh, great. Even the smart board doesn't want to wake up this morning. But Kyle's doing better. Okay. When t equals 13, what's going on? In 13 seconds, when t equals 13, wait, accelerate from. Is this an acceleration? Kilometers per hour? Accelerate from. I see the word accelerate. I mean, okay, this is time. What are these guys? Acceleration? Is that how fast you were hitting the accelerator pedal? Or is that velocity? Because velocity is speed. Speed is on your speedometer. On your speedometer is miles per hour. What is this? Kilometers per hour. Okay, you're in Europe. Whatever. It's your speed, right? Okay. So accelerate. Well, because your speed went up. It's telling you that you're accelerating from an initial velocity. Ooh, that's nice. To another velocity. Which velocity? V sub 13. V of 13, after 13 seconds, I'm at 80 kilometers per hour, and at 0 seconds, I was at 25 kilometers per hour. Why did we make it 0? Well, it was the beginning of the situation. I don't know. What time was it? I don't care. I can just make it 0. It was the beginning. There's a few different places where you guys have to make the beginning 0. But the beginning velocity wasn't 0, it's just the beginning time. Beginning velocity was 25 kilometers per hour. Now, if the problem said something like, we're measuring time, hours from midnight, and it's 9 o'clock, you're like, okay, beginning is 9. But this one didn't tell me that, so I'm like, okay, beginning is 0. What else? Assume. Assume the acceleration is constant. What does that mean? My acceleration is, can I just call it little a? I know it's kind of awkward. There's an a there and an a there, but can I just call it a? Sure. I can call it little a sub naught if you want me to be snazzy. But the acceleration function is a number, is a constant, is one variable. No t. It's not changing based on time. It's constant. It's staying the same. Is it negative 32 feet per second? No. Kilometers per? No. It's not gravity. This car is not. I mean, a car, I guess, it could fall. But this one's not. This one's just driving. It's not a gravity problem. It's not an up, down, something being thrown, gravity pulling it to the ground. But it's like that in that it's some sort of number. AKA, your foot is depressing the pedal at a perfect, or maybe not your foot. Maybe the machine is doing it. That would make more sense than the machine, because the automobile manufacturers already know this. A machine is depressing the accelerator pedal at a constant rate. Anyway. Or with constant pressure, I should say, so it's accelerating at a constant rate. This one says find the acceleration in meters per second, aka meters per second squared. Before we even stress about needing equations or solving or plugging in, does just reading the units have a ding 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 going off in anybody's heads? Yeah, because they didn't give me meters, they gave me kilometers, and they didn't give me seconds, they gave me they gave me kilometers and hours. I want meters and seconds. Do I need to build some bridges? So before I even worry about plugging in, I need to do dimensional analysis in chemistry. That's just part of math and chemistry. Dimensional analysis is just changing units to make them match. So I can make my 80 kilometers per hour. Quick hint, number 64 needed you to go from miles per hour to feet per second. Or I guess you could have the feet go to miles. It's just awkward in a decimal. But we could, let's see, 1 kilometer is 1,000 meters, right? 1 hour is 3,600 seconds. You're making that stuff up. No, I've learned math before. 60 seconds in a minute, 60 minutes in an hour, 60, 60. They're assuming by the time you get to calculus, you know some things like this. How many feet are in a mile? I don't know. Ask Siri. She'll 5,280. Okay. So we can go ahead and get meters per second, and if we do, I should have had a calculator close. Come on, someone converted last night. What'd you guys get? No one converted last night? Yeah. Oh, you didn't convert? You didn't convert? I think it's 200 over 9. If anyone wants to double check me, this is technically your problem that we're just going over questions to. You gotta convert. You gotta make it what they have it to be. Meters in seconds, not kilometers and hours. So we're changing that one. And we're also changing this one the same way. Okay, but pause. Come on. Are we tracking so far? Just I'm converting whether or not you remember to. Okay, so we're doing 25 times 1,000 divided by 3,600. P.S. I'm doing fractions because the decimals I would round, and when I round, I introduce error. And I don't want error. So I'm going to map frac. I'm going to do a fraction. 125 over 18. Okay. If you, in homework, ever see something to do with velocity, shouldn't you get a velocity equation so you can plug in stuff? Does that make sense? But if they don't give me a velocity equation, what they gave me was acceleration being some constant. How do I get velocity from acceleration, even if I don't know it? Integrate. Because it's a, Kathleen, who is this guy? What type of quantity? Variable or constant? And how do I integrate a constant? But it's not an x. So it's going to be a sub naught t. She called hers yesterday d. She was doing number 64. She had to do dt, which plus c. But it worked. This one I just made it a to make it easy. Plus c. Wait a minute. Hold on. Who did we figure out for this type of easy motion c is? 25. Yeah, it's going to be the initial velocity. If you need to see it, just plug in your clue. And your clue is at 0. My velocity is nope. Yes. 125 over 18, which equals my unknown dude when time is 0 plus c. Check it. These easy guys. Plugging in 0 will cancel everything but the c, which is why I'm able to do this like, oh, c is the initial in the right units. Now, I'm going to prove a point to you. I'm putting meters per second. Dimensional analysis is technically just called keeping the units in the expressions. However, we need to keep going. Keep going. What? Oh, find the acceleration. This one's actually nice and easy because they told you exactly who you needed to find first. In number 64, it doesn't tell you to find the acceleration, but the key is finding the acceleration before doing what they're asking. So 63 came before 64 because 63 told you what you need and then what the main point was, and 64 just says, okay, can you repeat it? What other clue do we have besides initial velocity? Check! Used him. Yeah. So can't I do this again and say, haha, I have one thing plugged in. Now I can say v of 13 is 200 over 9, which equals a sub naught times 13 plus 120. Oh my goodness, guys, come on. It's a simple algebra 1 equation with fractions. Okay, so if you're algebra 1 self, your itty bitty kids, you might have freaked out a little bit, but we got this. We have calculators. 200 over 9 minus 125 over 18 divided by 13 made into a fraction. Ooh, that's gross. A sub naught is equal to 275 over 234. Oh, but we're giving a final answer, which means I can do it as a decimal. Oh, I don't want it as a fraction again. I want it as a decimal, which would be 1.175. Calculus always rounds to how many decimal places? Tenths, hundredths, thousands. Good. And what are my units? Well, hold on. Wait a minute. So this was meters per second, and this is seconds, and this is meters per second.
Meters per second squared.
So if we subtract, then we got meters per second. And if we divided by seconds, oh, That's why it's meters per second. And that's why I needed to change my units, or else I'd have kilometers per hour per second, and I'd have some deep issues as far as making it match. Since they're already what I need them to be, when I divide by this second dude, I have my meters per second. Yes, how, if you want to be super snazzy, this is how much your velocity in meters per second is changing per second. Every second that goes by, your velocity is increasing by approximately 1.175 meters per second. But we don't usually write it like that. We usually write it as 1.175 meters per second squared, which is a simplification of the units, but doesn't show the idea as much. Like, oh, it's how much your velocity is changing in meters per second each second that goes by. Anyway, did we find acceleration? Yes. Did we have to do a system of equations? No. It was actually super easy as long as you converted. And plugged into, ew, we didn't have a number. That's okay. We can still integrate constants using rules. Just pretend he's a k. And what's the integral of any k? Didn't you memorize that in your forever card? The integral of a k is a k times x, but this is just a t. What's letter B say?
And the distance.
Distance? Ah, I can't stick with acceleration and velocity. I need to go to? Yeah. And how do I go to position if I know velocity? Integrate. So I have up here my, oh, I have it now. 275 all over 234t plus 125 all over 18. So my position would be, I have to divide by 2. 275 divided by, well, times 2 is 468. Because it's t squared over 2, and so those two combined. And then I have 125 all over 18t. Now here's another place you might get stuck. What's your initial position? I don't know where he was. Oh, just make it 0, because you're measuring how far away from where he started. So when you see this 13 seconds, it was like, okay, well, how far did he go? Not where is he from his home or the mall or school, just, or the North Pole, but just how far did he go? Oh, cool. Okay. We can just make his initial position 0. See, in physics, that's not necessarily us pulling things out of thin air, but it is showing you, okay, there are a couple places where you get to say he started at 0. How far did he go will be the next position. Oh, wait a minute. Once we have this, all we have to do to finish the problem is say, what's time?
13.
Ah, easy. Plug it in, plug it in.
Easier than concept.
It's easy when I do it. It's harder when you're stuck at home alone. Oh, you should never be alone because you should always have some calculus person to speak of. Not that that's an actual thing anymore, but still, you know what I mean. In your Snapchat or in your DMing or on your FaceTiming or whatever you want to, however you want to communicate. And I end up with, I believe, I'm allowed to round since it's a final answer. I can't say equals because position, the general position function doesn't equal, but S of 13 does. Equals 189.583. What does that mean in context of the problem? During those 13 seconds, he went that far.
Hello.
Dun, 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 dun. Number 64 is similar. I don't know if I want to do it because we just went over the odd that you struggled and had CalcCAB with. I think I want to let you do 64 or think about it this weekend a little bit more. Sound good? And if we need to, we'll go over 64 on Monday, Tuesday. We have school off on Monday, but you need to remind me because you know me. I'll forget. I'll be like, we already did that. Okay, where else in homework or, well, let's check evens. Let's check evens. We were able to go ahead and do one odd where at least one or two or all of you either got stuck or struggled. Let's do some odds. We're in not A. That's the basic ones we already graded. B. Here we go. Do you guys realize I gave you quite a bit of odds, right? I gave you one even here, 54, two evens here, 60 and 62, and one even here. Most of them were odds, and that was on purpose. But number 54, the first even. I believe it was just looking for position. but you had to go looking for time first, using the clue that a max always happens when velocity is 0, plugging in gravity with an initial velocity. Your final position, I'm guessing when it hits the at its max, how high does it go? Is 7.1 meters. Did I get there? Is it the highest that it goes? Is that number 54? Perfect. How did I know that? Just the math. I don't have the problem in front of me. Okay, if I looked. I didn't look at the problem in front of me. I figured out they're setting velocity equal to 0. Okay, cool. And they gave me a hint. But I knew that they were finding when it was at the max, and then they found where it was at that time. Now, hold on, guys. They say approximately, which means they rounded. You should have 3 decimal places, not just 1, right? Yeah. You should have 3 decimal places. Someone help me out. Be confident. You're like, I rounded, right? What's the 3 decimal places? 7.102? Perfect. 7.102. Calc, AP, exam, always 3 decimal places. Never a tenth. 7.102 meters. Number 60. Oof, there's an A, B, and C. Number 60, letter A. You were just trying to find the velocity function. Yeah, you were just trying to find the velocity function. They gave you position. Oh, this was old school. Section 2.2 stuff. Take a derivative for him. Acceleration. Take another derivative for him. That's cool. Letter B is asking for when you're moving to the right. Am I correct? How do I know that? I see them asking for when velocity is positive, and when velocity is positive, my object is moving to the right or up. I'm just guessing to the right. But how would you, they showed no work.
How dare they?
What work should you have shown? A sign chart, because we talked about that yesterday and put it in our notes. If you need to figure out when something is moving to the right or the left, my guess is they're starting at t equals 0. There's some sort of domain, t greater than equals 0. We have some critical numbers of 5/3 and 3. 5/3 is less than 3, and then we have 3. And then they checked their signs. And guess what? This one ended up being positive for velocity, and this one ended up being, did it stop at 5? Was it between 0 and 5? So then when is this guy moving to the right? Only when the velocity is positive. You needed to do a sign chart using your critical numbers, aka your zeros of velocity. Are we good?
Yes.
Acceleration, all you had to do was set him equal to 0 for letter C and then solve for the time, but they didn't want the time. They wanted the velocity at that time. Check it. We just keep on playing back and forth with our clues. So we knew acceleration had to be 0 at that time. We can plug it in and figure out the velocity is -4/3. That's a negative, sorry. Negative 4/3. What are the units? I don't know. They didn't give it to you, so okay, I'll let you off on those ones. And then number 62, and then 64 is that one you can take a picture of if you want and ponder it this weekend with what we did on 63. Let's be honest, ponder it on Monday night. No, do it before that. So anyway,
Monday morning.
On number 62, you had an acceleration that was not constant. So my physics guys that are like, I just plug it into that 1/2 acceleration t squared plus velocity t plus position, all initials. This one wasn't constant. You can't plug into that formula. You need to actually integrate. And when you actually integrate, then you can get a function with a plus c, but you can't necessarily just plug in your initial. You have to actually say, my clue is f of 0. F of 0, cosine of 0, is an actual 1, so you had to really solve for c. You couldn't just be plugging in initials. Remember, that was just a shortcut because everything in our other equations, our free fall equations, would be 0, so c was initial, but this one, I got this guy that I have to move to the other side. I end up with my position function. They're calling it f. You could be calling it x or s. That's totally fine. And then letter B is tricky because some people were like, it's sine. Doesn't sine hit 0 lots of times? Yes. So they broke that in a funny way. They were like, hey, 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. They're saying it's all of the pi. What's the snazzy way in pre-cal that we wrote multiples of radians? We didn't use k, we used
R.
nobody. Plus 2 pi n? Plus pi n?
Yeah.
Where n was within all integers. But this one, the problem is it's not within all integers because t is greater than 0 or greater than or equal to 0. So it'd be within all positive integers, all positive multiples of pi. So some of you guys stuck there, but yeah, you're right. There's infinitely many. They just wanted you to know, like, oh yeah, it's going to happen every time we're at pi. And then number 64, I'm just going to pause. If you want a picture of it, take it. If you want a picture of it, take it. Remember, we'll talk about it on Monday. For right now, guys, I would love to go to our motion packet. Unless there's something where you're literally like, I cannot keep going on this motion homework and I'm horribly stuck unless you answer this question. And I don't mind. Let's not have it be on 64 because we did 63. Is there anything earlier in the homework that you want to talk about? Or another odd that you're like, literally, I don't know how CalcChat did. We're okay? So let's go ahead and get to our motion packet, because remember, isn't that one due Tuesday? We want to finish as much as possible today.
Yeah.
And we want to listen very carefully if I say something like, oh, okay, you only have to do this and this and this and this section for Tuesday. So maybe grab out a highlighter or a colored pen, or you could, I guess, just circle things as well. I'm just getting Algebra 1 ready, sorry. And then this one, we can just go to our notes. Okay. So in our motion packet, we were on worksheet number 1 yesterday. We're going to try to get to example 2 and 3 is my hope. Getting to the speed increasing and decreasing, and then let you guys go ahead and play with finishing the rest. But let's go ahead. Worksheet number 1, or example number 1, I should say. Let me zoom in. We don't need to have more than one page. Zoom, zoom, zoom. Hey, motion. Who was that little guy who was like, was that Audi? Anybody remember those? The little guy in the commercial. Oh, this is sad. Back when we used to watch TV. Okay. Back when we all used to watch TV. Now we just have whatever commercials gives to us. Or YouTube. We are on worksheet number 2. Sorry, but example number 1. Okay. We talked about when the particle, if the particle, when the particle must be at rest. The only one we know for sure is between here and here, because these are velocities, and we know velocity is continuous. So therefore, because of the sign change, there must be a 0 by MBT. Because of the sign change, there must be a 0 because of MBT. Now, guys, I did skip a kind of crucial step that I probably should have put at the beginning, but it's motion, and so motion is always assumed defined. But we could go ahead and for future problems where this is not position, velocity, acceleration, but just original rate and rate of rate, which is different. It's not just motion. There's movement, but not like physical motion. We could say since velocity is continuous. For IDT, you technically have to have a continuous function. If it's not continuous, it can jump from here to here and then never go through 0. If it has a break, a jump, a vertical asymptote, it can skip 0. But if it's continuous, it cannot skip 0. So we're on number 3. Use the data from the table to find an approximation for v prime of 10 and explain the meaning in terms of the motion of the particle. They don't just want the number, they want what it means. But come back. Now, before you ever finish a problem and move on, you should reread it and make sure you got all the pieces. But let's start with one step. And sometimes it's nice to underline it and be like, I'm trying this. Haha, I did it. Then be like, I'm trying this. Haha, I did it. And then I'm doing this. Got it. That's one way of your brain saying check, check, check. Approximation for v prime of 10. Approximation for v prime of 10. How do I approximate a derivative? S of b minus s of a all over b minus a. How do I approximate an instantaneous rate by an average rate? And that's what the OChem tutor guy, what did we call him? Alan? Alex? Was that not this class? One of the classes gave him a random Jared. Thank you. Jared was using that as an example of saying the secant line approximates the tangent line, the average approximates the instantaneous. Sweet. So hold on, wait a minute. But we want something near 10. What's near 10? 8 and 12. We're going to to use these guys. So we can go ahead and do, wait a minute, V prime. So it's not S of B minus S of A all over B minus A. It's not average velocity approximating velocity. It's going to be average acceleration. I'm not doing S of, I'm doing V of, because I want V's derivative. So I can go ahead and plug in 5 minus 7 all over 12 minus 8. That is my average acceleration. Average equals this. Wait a minute, that'd be meters per minute squared. Oh, I don't simplify a lot. Meters per minute, meters per minute, to check it in the back of the book, meters per minute squared, which approximates V prime of 10. See how I'm kind of bringing it all together? My average acceleration approximates. Oh, hey, wait a minute. They wanted me to explain the meaning. Okay, so forget this. I'm going to write it in words because they want me to explain. So I can go ahead and say, oh, I don't have a lot of room. Why are we hydroflasks? Why are we doing that? Oh, stinkity.
What?
What are we talking about? Who died?
I keep dead beings alive.
Oh, there we go.
I keep the dead alive for 4 years. Joe alive for another. Who's Joe?
Explain the meaning of V prime of 10. Oh, same with the meaning of this. The acceleration of, who is this guy? The particle.
Who are you?
The acceleration of the particle after I don't like saying at if after makes more sense. After how much time has passed? After 10 minutes. Look, it's as easy as that. V prime is acceleration. You're just filling in the forever part. Acceleration of who? Go look at the problem, the particle. You can even say the particle moving along the x-axis if you want to be snazzy and write a whole story. The particle after 10 minutes. So after it's been moving 10 minutes, this is an approximate for its acceleration. It's as easy as that. Show the computations that lead to your answer. There it is, because why? They're giving me a point for just that, and then a point for whether I did it right, and then a point for my explanation. Indicate the units of measure. Yeah, I already did that. I'm a good math student. Dun, 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 dun. Number 4, let A of t denote the acceleration of the particle at time t. Is there guaranteed? Does this sound like a theorem? Is there guaranteed to be a time t equals c? Oh my goodness, I think it's like an IBT and MBT. There's a c, dude. In the interval 0 to 12, such that acceleration is 0. Wait, isn't acceleration? Didn't we just say it's the same thing as v prime? What theorem has me looking at guaranteed derivative values? MBT says such that f prime equals. Ooh. Ooh. Well, wait a minute. Hold on. Isn't 0 a special MBT? Isn't that Rolls, dude? Doesn't Rolls apply if my value at A and my value at B are the same? Meaning, okay, well, it went through and somehow passed and then somehow back to. So therefore, there had to be like a flattening somewhere to get from and to the exact same place. Do we have any velocity values that are the exact same values so we can say, ooh, it went up and down or down and then up? Right here. You guys remember how I said yesterday that there is some sort of increase here and some sort of decrease? Now maybe there's a lot of increasing, decreasing in between, but somehow it went up and somehow it went down? Okay, hold on. I'm trying to think. Do I want to show you what's helpful for this problem or what's helpful for all the future ones since this one are almost all APs? Yeah, let's do the second one. Ready? In this one, I could have said, hey, v of 6 equals v of 12, rolls applies, dun 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 dun. Oh yeah, it's continuous and differential. That's all. That'd be enough. The problem is, in other APs, can you guys come back here because we haven't used him yet? Can you, in your table, make this a 6 instead of a 5? Future APs won't give you the 5 and 5 because too many kids got used to rules and they just saw it and they're like, I don't really know what's going on, but I've memorized because my teacher trained me. I'm a little monkey and I can say, yeah. And they're like, oh, we don't like that. We want kids to think harder.
Still goes through. Done.
So, there's still a guaranteed 0, but not because of rules. I don't see a 5 and a 5. Now, does it have to hit 5? Yes. Could I go ahead and use an IVT and say velocity is 5 somewhere between here and here because velocity is continuous, and so wherever that is to wherever this is going to be a rolls? I could do that. But the way that the AP more, actually that's an interesting way. I've never actually done that before. Huh. That's interesting. Anyway, never thought of that way, is making rolls work. But the other way that they do it, guys, is using MVT twice, here and here. What do I mean? On an interval, for a continuous and differentiable function, MVT's hypotheses or conditions, ready? Track with me. On an interval, like 6 to 8, doesn't the instantaneous rate need to equal, doesn't f prime of c need to equal the average rate, f of b minus f of l over b minus a, at least once? Yes. So, on the interval 6 to 8, question, what sign is the average rate going to have? On average, did this increase or decrease? Is velocity positive or negative? Yes, on average, velocity is positive. How can I show that? As v of 8 minus v of 6, all over 8 minus 6, and I can say, hey, it's greater than 0. It's a positive velocity. I don't even have to say what it is. I can just say it's greater than 0. On average, what's the velocity from 8 to 12? By IVT, if I have an average which is an instantaneous that's positive, and then I have an average which is an instantaneous that's negative, what does the instantaneous have to do to go from a positive to a negative? AKA pass through 0. Sign changes only occur at 0 for continuous functions. So we're going to go ahead and try to take all of that and put it here. Okay? So we can say, since velocity is both, oh, that's great, is both continuous. Kathleen, I think you asked me if on the AP you can abbreviate. In these ways, yeah, continuous and differentiable, pretty obvious. Since velocity is both continuous and differentiable, MVT will guarantee V prime of t will equal V of b minus V of a all over b minus a for each interval above. So far so good? I'm just stating MVT. Since velocity is both continuous and differentiable, MVT is going to guarantee that the instantaneous, hey, can't I make that acceleration? Because they're asking about acceleration. So acceleration, which is the derivative of velocity, will equal on. Let's say on. Oh, for. Let me say for. Keep that. For each interval above at some x, we're doing t's, not x's, right? Some t within a to b. Got it. For each of the intervals above, grammar, at some t within a to b. Okay. Therefore, on, where are we going? 6 to 8? have to be equal to v of 8 minus v of 6 all over 8 minus 6, which is a positive, for some C1 within 6 to 8. And on 8 to 12, acceleration, which will equal, or will equal, v of 12 minus v of 8 all over 12 minus 8, which is negative for some C2, this is a different C, within 8 to 12. By IVT, because we already stated that velocity is both continuous and differentiable, right? By IVT, since acceleration is continuous, and Adam, you said it, there is a sign change. On 6 to 12, somewhere in there, bless you, A of t must be 0 at some point within that interval. Good in the AP, like, gives you a question and then a big old box underneath to be like, hey, like a blue book in college if your older brothers, sisters have been in college, or cousins, parents, aunts, uncles. Anyway, you just write. We could have probably condensed this a little bit, but this is what the AP rolls, even though it's great and it used to be easy, they've taken it out and they've changed one little thing so they're not the exact same, so you can't go as quick and easy and be like, ha-ha. You have to say, oh, there was an average increase, an average decrease, therefore there has to be an instantaneous increase, aka V prime positive, instantaneous decrease, aka V prime negative, and there must be a sign change. And you have to state MVT and IVT in your analysis. So you can't state a theorem or you can't get full points for it if you haven't proven it's applicable, aka using those things like, oh, it's continuous, oh, it's continuous and differential. Hence why I have you memorize those forever cards word for word. Kind of makes sense? Okay, now I know it took a lot of time, but this is a big question that shows up almost every year somehow, somewhere. Anytime you see a table, be looking out for MVT, IVT. Huh? Hi.
Do you have the answer key on like Monday? So we can, like,
For the motion packet?
Yeah.
Do you guys like that idea? Let me go ahead and tell you which ones I want you to try for Tuesday, though. Okay? We're not going to have the whole thing. So ready? I want you to circle the following for Tuesday, what I want you to try. This worksheet, or sorry, example number 1 was given a table. And it's tricky because tables are just like little snapshots. You don't have a nice little function. Example number 2 gives you a graph of a derivative. Can you guys label this? V equals S prime. Do you remember how we would be given graphs of derivatives before? Remember how we did a derivative graph match to visualize the original or the second derivative? Graph of a derivative. I want you to circle this one. I want you to try example 2. I want you to circle example 3. Oh, he's nice. What's example 3 give you? Love them. Love equations. Love equations. Except on example number 3, can you do a little slash through number 4? We haven't learned the formula yet for total distance traveled. So just put a little slash through number 4. That was number 11 on the first page. Pause, pause, pause. And then, don't worry about that. Then, can you guys do, no, we'll do that together in class. Ooh, I'm gonna take more time on this. Do worksheet number 3. And that's it. Do worksheet number 3. You're basically filling in stuff to a table with absolute values. The best you can. So I'll post answer keys to those ones that I said. Sound good? Okay. We're doing a lot of AP prep, guys, so hang in there. I know it's kind of messy and this thing's taking a long time, but it's okay. It's worthwhile. And some of this we'll come back to a little bit later on this year. Bye, guys.